Hi and welcome back. I hope you've enjoyed our previous videos, and I'd like to just take this moment in time to say could you please subscribe and like the video so that I can get some feedback as to whether or not these are useful. Okay, so if you want to follow along, you need to be opening up a Jupyter notebook using Anaconda Navigator, which I've explained before. And what you will need to do is you'll need to do File and New. And as before, I've got one here that's ready to go. Okay, so once you've saved your files, by the way, just clicking on them opens them in a new window. So what we're going to look at in this video is backtesting a strategy that uses a technical indicator. What that will involve is making a trading signal from that technical indicator, which the BT package can use. So in previous videos, what we've done is looked at the BT package briefly and the algos that it uses to control the flow of a strategy. And we created a simple backtest of a simple strategy of buy and hold for a week. And we also looked at using the TA library, the technical analysis library, to get values for technical indicators as well, just a few of them, and looked at the format that's used. Okay, so let's start working through it. As before, I'm not typing it out. You can just see on the screen what I've done. So first thing we're going to do is to import the packages that we need. So again, the BT package, the TA lib, and we'll be plotting some information. So we'll be plotting some of the results. So we need the matplotlib package. And what I've also done is this line here means that it configures the charts so that they use the entire screen. Okay, so as before, I hold down the shift key, I press return, and that executes that. So let's look at a simple signal-based strategy with a simple moving average. There are two primary ways to backtest strategy. One involves using the select where option, and that's what we're going to do here. And that's going to select where price is above a 20 period simple moving average. Now we are simplifying this because we're not taking into account things like slippage or commissions, which in reality often do have an effect. Okay. And I also do need to add in that this is not financial advice. I am just a software engineer, and this is sharing with you programming skills that I've learned to deal with this type of project. Okay, so let's move on. So the first thing we're going to do is we're going to get the price data, and then we're going to calculate the simple moving average. Okay, so we've gone through this before, and when we use the BT package to get the price, we get this column with the ticker name Goog. So this one is the Google company, and the index is the date stamp here, which we've been through before. So the next thing we need to do is to define the strategy. So this is what we've got here. The BT strategy is equal to, and then this is the format. So we've given it a name, and this time you can see this select where, and then we have this condition. So the condition is going to be when the price data is greater than the SMA that we calculated up here. Okay, so we're going to execute that. So shift and return. And then here's the backtesting going on here. So we're going to create the backtest using the strategy which we've just defined and the price data. Okay, then we're going to run it, and then we're going to plot the results. So holding down the shift, pressing return. A little bit of a delay there. So as before, BT package produces the results which we can then plot. And you can see the results of that backtest here, and you can see that overall from the period of 2020 to 2025 it's not bad. It gives quite a good return. Not so good if you'd have started it in for example, 2022, you wouldn't actually have much of an increase at all. Okay, so moving on, we're going to look at a slightly more complicated strategy, which is a moving average crossover. So this particular one is quite common. It's referred to as the Golden Cross, where a short-term moving average crosses over a long-term moving average. And just want to say once again, this is not financial advice. I am not a financial advisor. All I am is a software engineer explaining how I do some coding. So first thing we're going to do is get the price data again. We've already got it before, but we can get it again. And this time we're going to use the TAlib library to get an EMA. Okay, so we're going to do an EMA 50 period. I'm going to save it to a variable called EMA short. By putting 2 frame at the end, this will make EMA short a data frame. Okay, and we're going to have a similar thing with EMA long, but with a 200 period look back. So just selecting there and pressing return. That's that done, and then we can have a look at them. If I again shift and return and then scroll up, so here you go, just showing you the data type there by this command. So just showing you that it is a data frame and just showing you there what the data is. And of course at the beginning of the series there's going to be NANs, not a number, because there won't be enough data to calculate values at that point. Okay, so what we're now going to do is we're going to construct a signal, and that signal will then be set to a 1 for a buy, a -1 for a sell, which you can do if you're doing things like contract for difference, CFDs, and 0 for no trade at all. Okay, so that's what I've just explained here. And in this particular instance, if the short-term EMA is greater than the long-term EMA, the signal is going to be set to a 1, which, as I say, will indicate a buy. And if the short-term EMA is less than the long-term EMA, the signal will be -1, indicating a short position. So it's always going to be one or the other with a crossover. There isn't a 0 where you just don't hold anything. Okay. So the first step is to create the variable called signal, and to do that we're going to copy in the EMA long data frame, and then we're going to set those NANs to 0. All right, so if I do that, and what I will actually do is we'll just look at signal there, and you can see that the NANs have been set to 0, so that's been done with this is null function. Okay, and we could of course set it to something else by changing that value. I'll go through that in another video. So what we now want to do is we now, as I say, want to make it so that if the short-term EMA is greater than the long-term EMA for this signal, we set it to a 1. And oh, my dog's barking, so I need to pause. Okay, I do apologise. Just had an interruption here with my dog barking. Had so many interruptions with them this morning. It's crazy. Okay, so where were we? We've created this signal variable, and we've set the NANs to 0 there. Okay. So what we're now going to do is we're going to go through and use indexing based on a condition to set the value to 1 or -1. So this is going to work through that signal data frame, and in the positions where the EMA short is greater than the EMA long, it will set it to a 1, and where it's the other way around, it will set it to -1. Okay, so that would change all of the signal to either 1s or -1s when we run that. So I'm holding the shift key down, pressing return, and you can see it just happens to be that to begin with, obviously there's no numbers, so they're all zeros, so that won't work. They'll always be set to a 0, but you can see there's some -1s there. Okay, what we are going to do is we're going to plot it out so you can see the signal with price in a minute. before we do that, we're going to rename the column. At the moment you can see this has got a column title of 0. We're going to rename the column Goog so that it matches the column title here, because that's what's needed for the backtest library to work. Okay, so just coming back down again, so that's what this line is here. So when we enter that, we're going to change the name of this column, and we will look at it just again. So now you can see it's got Goog above it, so it matches the price data. And now we're going to merge the signal and the price and the EMA values, and we'll just get a visual confirmation that we've created a signal which is matching the strategy that we're trying to do. All right, so nothing too complicated. I've created another data frame, and I've merged the signal, the price data, and the 2 EMAs into that. I've renamed the columns, and then I'm plotting it, okay, with a secondary axis, which is the signal. So again, we've got a nice wide plot, and that's because of the command that I put up above. So what you can see here is, at this point here, this is the signal line. I've got no signal to begin with because the EMA long has not yet been calculated. As soon as the EMA long has been calculated, our comparison comes into play. So in this particular instance here, where we start, the EMA short is above the EMA long. So that's a buy condition. So the signal goes to a 1. So we've got this secondary axis here, which is the signal, which is -1 to 1. And we've got the axis over here, which is the price data. Okay. So you can see at the point it crosses, at the point where the short, the EMA short goes below the EMA long, we can see the signal swaps to a -1. The EMA short is below the long term, so we've got a signal of -1 all along there until the EMA there overtakes the EMA long. So sorry, until the EMA short overtakes the EMA long, and then we get back to a buy condition. So this gives us like a nice visual confirmation that our signal is working as we expect it to. And once we're happy with it, as before, well, not quite as before, but we're going to use the BT package, but this time we're using the way target function with the signal. Okay, so this time the strategy is running with this way target as the signal. And again, press shift and enter. Not sure why that I've got price data there, because we know what the price data looks like. So I'm just going to skip that one, and I'm going to go to here where we're going to create the backtest and run it, and then plot the results. Okay, so this is as we've seen before. So shift and enter, it chunks away for a little while, and then here's our result. Okay, so to begin with, there's no return. That matches this period where we didn't have enough data. So we've got a flat, and then from this point of view, we pick up, and this is our returns on this golden cross strategy. Okay, so so the strategy above was using moving averages. Okay, that was a golden cross strategy. Let's look at another simple one. A lot of people follow, or my understanding again is that they use the RSI, which we looked at in a previous video, the relative strength index, to detect whether or not a ticker stock is oversold or undersold. And so we would create a signal where the short signal would be an RSI of greater than 70. So that's oversold, so you're expecting the stock price to go down a bit or the asset price to go down. The long signal would be when the RSI is lower than 30, and that would be that it's been undersold and you're expecting it to go up, and then no trade would be in between those. Okay, just want to say again, remember this is not financial advice. So first thing we do, we'll get that data in again. We don't have to bring the data in again, I just do it. I've just put it there because sometimes I haven't run what's above. So we're using the Talib library to get the RSI data. All we need to put in is the price and time period, and again we're saving it to a data frame. Okay, so in this particular instance what I'm going to do is I'm going to print the results of that, and then I'm going to plot it to see what it looks like. And so you can see here is our RSI going up and down. So we're going to create the signal data frame the same as we did before. We're going to copy in the RSI, and then we're going to set the zeros to so we're going to set the NANs to 0, which is what we've done. And here's our logic for the signal. Okay, so again what we're doing is indexing this signal data frame, and what we're saying is we're indexing all the values where RSI is less than 30, and we're going to set them to 1. Then we're indexing all the values of the signal data frame where RSI is greater than 70, and we're going to set them to -1. And then we're indexing essentially all the values in between and setting them to 0. Okay, and then in the same step we're going to rename the column, because just in case you missed it before, the signal data frame has a column of 0, and we need it to match, where is it? We need it to match the price, which is all the way up the top here. We need to make that column name match the column name in the price data. So in this particular instance it's the ticker Goog. We need to rename it to Goog. So let's go back down again. So RSI, so we've done that bit. Here we go. Done that. So shift enter in there, shift return rather, and we've just executed it. So we've set, in this particular instance, we've got the beginning and the end of the data frame is 0, but we've got Goog there. Okay. So again, what does this look like? Let's merge the signal with the RSI, because that seems to make more sense than merging it with the close price, because we want to see whether or not we've created a signal that looks sensible. Okay, so we've got two columns, signal and RSI, and we've got the secondary axis there as being signal, and we've got plot. Okay, so again, holding shift, pressing return. So what have we got here? So RSI would have gone really high, so we would have had a -1 just briefly. So kind of just might be worth at this point saying that this is slightly different from how a lot of people use the RSI, because this literally is saying when it goes below 30 it buys, and then when it goes above 30 or is even is equal to 30 it closes the position. Okay, so yeah, if it goes equal to 30, position's closed. Same thing with the sell. Okay, so if we go down here, we can see it went above the 70 figure briefly, so we've got that. Then it dropped back down again, so we've got no signal, no position. Then here, just about touched, so it's dropped down again. And I could put lines to make it slightly easier, but I just haven't. You can see it's dropped below 30 on a couple of points there, so we've got a couple of buy signals there. So it looks as though it's working. Okay, so again, that looks like it would have been a sell signal. So yeah, we've got a couple of sell signals there. Up here again, same sort of height, couple of sell signals, nothing below 30 until we get to here. Got a buy signal. So this just gives us a bit of a visual indication that we've created the signal correctly. Okay. My apologies, because that can go. I've obviously got that bit in there twice for some reason. So once we've got this visual confirmation, we can do what we did before. We can define a strategy, and we can use the signal as the argument to the way target function, giving it a name, RSI mean reversion. Okay, then we've created the backtest using the strategy and then the price data. We've run the backtest and we're going to plot the results. So just pressing shift and return, and here's our results. Quite a nice steady increase actually, without too much of a drawdown. However, we're going to look later on in the series, we're going to look at actually how you evaluate these strategies, how you can quantify and compare one strategy against another, but that's a video for another day. Okay, so I hope you found that useful. Please like and subscribe to the video so you get notifications of the next one when it comes out, and I'll see you next time.